And we welcome all of you tonight. This is our monthly meeting, which it's a joint meeting between Tualatin Heritage Center and the Lower Columbia chapter of Ice Age Floods Institute. We were actually founded in 2005. I was the co-founder at that time, and have been very active in this chapter ever since, particularly acting as treasurer primarily. So we welcome all of you tonight. It's going to be a marvelous meeting, and I just think we need to go ahead and get on with the meeting. And let me just see if I didn't forget anything there. I did not, and I would like to introduce Larry. And Larry, go ahead and introduce Andrew.
Well, thank you very much, Charles. It is a pleasure to introduce someone who's a real friend of Scott Burns, who's a name well known to us in Tualatin. He lives here and has done his geology work here early on by poking around in a big gravel pit out here, which is now where the Bridgeport Living Center, they call it, Bridgeport Village.
That's right.
He did his early work there, but went on to greater fame, and we see him sometimes on television, of course. But tonight, we're talking with a fellow here that Scott recommended as a great speaker for us, probably the leading expert on glaciers in the Northwest for sure, and even around the world. If you look at his pedigree online at Portland University, you'll see all the places and projects and writing he's done. I think the most recent one was related to the Olympic Peninsula, where he's got some predictions there, which you might even talk about tonight. But I am pleased to just welcome Andrew and taking his time away from retirement to join us here and tell us all about what we ought to know then and now about glaciers that we know and love in this region. Welcome, Andrew. And I also want to mention, if there's a question anyone has, there's the preferred way for during the presentation is to go to the chat box and enter your question there. But if you have a question afterwards, after he's finished, then you can press your space bar and it'll open you up. Your voice will be heard by everyone and you can ask your question then. So let's begin, Andrew. Welcome again.
Well, thank you very much, Larry. Normally I'd say I'm glad to be here, but I'm at home. I'm sorry that we couldn't all get together tonight, but you know, that's the way it goes. But having said that, happy to be here. So, this lecture is going to be kind of in two parts. The first part is going to be, well, how do we understand that there's glaciers out here? What's the history of glacier studies? And then the last part is going to be what are the changes of the glaciers that we've observed over the last 100 years and the next 100 years? What do we expect to see? So, and I'll give you a little forewarning. The story doesn't end well, so brace yourself.
Right.
So I'll try to share my screen here. Let me know if you got it.
Yep, got it.
Okay, great. Okay, so this work that I've been involved in over the years really is a collaborative effort between myself, a number of individuals here in the Northwest, as well as a lot of students that you see down in the lower right, some of whom I still work together. And as interesting as the science is, working collaboratively with friends and colleagues is really where the joy is. So, a number of years ago, I've been studying glaciers now for about 40 years. And at one point, not long ago, I thought, who discovered the first glacier? Did people always know that they were here? So I started tracing this back a little bit, and the story became more and more interesting. And I'll share that with you. It starts out with the California Geological Survey. You see Josiah Whitney here, he's the director, and the other main character here is Clarence King, who eventually becomes the first director of the U.S. Geological Survey. In 1863, Clarence King here went west and volunteered for the California Geological Survey. Um, Whitney was a Yale man, Harvard man. King was a Yale man. You know, they shared a number of acquaintances, and King knew about the studies out there, and he kind of made a beeline to work with the survey in California. And what's interesting is this is 1863 when most men of his age were serving in the army. So how he got out of it is an interesting notion, which I've yet to kind of find an understanding for. Anyway, back to Whitney. So Whitney was the premier geologist on the West Coast, and he wrote this guidebook, the Yosemite Guidebook. And this is what you're seeing here now is a review of that book in Nature. And I'll just highlight a couple of things. Up here in the upper right, it says that Mr. Whitney does not believe that Yosemite is formed by glaciers. Instead, he thought it was fault blocks where the earth separated and part of the crust dropped down, forming Yosemite National Park, or what we now know as Yosemite National Park. And we know where that kind of went. And then also, he says down here on the lower right that there are no glaciers in California. And the reviewer of this book down at the very bottom there says, well, boy, that's really hard to believe because Mount Shasta seems to be snow covered all year long, and there are no glaciers. So even at the time, there's a little bit of disbelief about the fact that the notion that there could be no glaciers in California. So that's the background. No glaciers in California. In 1867, Clarence King, pictured here with his field party in just outside of Salt Lake City, King lobbied Congress for $25,000 to mount a geological expedition along the 40th parallel. And the area that he proposed to cover is in this dark shading, basically from Colorado all the way to California. Now, King was only 26 years old. He talked Congress out of $25,000 right after the Civil War, when the government is in huge debt. That $25,000 is equivalent to a little better than $500,000 today. You can't talk Congress out of $500,000 now, no less back then, and particularly if you're just a 26-year-old. So this kind of underscores the kind of person he was. Incredibly intelligent, probably a genius, very well connected, and incredibly personable. He was the guy that you wanted to have at your parties. He made your party because he could talk to anybody about anything. And he was a tremendous enthusiast. So here he is pictured. He's in the field here, and he was one of the people that believed you dressed for dinner, no matter where you were. And in his field tent, he and his partner, as well as the cook, always dressed for dinner. By the way, he had a double life. His other name was James Todd, and he used to ride the Pullman cars across the West in this different identity. So I highly recommend that you pick up a biography of this guy. It's incredibly interesting. More than just a genius geologist, he had this kind of mysterious aspect to him. So anyway, so King has his field work in the West starting in 1867. and he's mapping all across the West. But he eventually makes a beeline to Mount Shasta, here pictured in the upper left. Why Mount Shasta? It's unclear. His advisor, Dana, as in Dana's manual mineralogy, Dana did a lot of research work here, so maybe he was influenced by that. Shasta was thought to be the highest peak in the West. Maybe he was excited about that idea. But nonetheless, whatever it is, he goes to Shasta and he climbs up Shasta, and here he is on a glacier, and you can see him right here with his alpine stick, his alpenstock. And he says, I've been to Switzerland. I know what glaciers look like. This is a glacier. And he publishes that. But he names the glacier Whitney Glacier. So there had to be some joke there, right? He was a loyal lieutenant of Josiah Whitney, who said there weren't any glaciers in California, none on Shasta. And here he names the glacier after Whitney. This had to be kind of a good joke between them, although I don't think Whitney thought it was that much of a joke, based on his later writings, who continued to say that there weren't any glaciers in the Sierra. By the way, Whitney is the same thing as Whitney Peak. It was named after Josiah Whitney. So King goes to Mount Shasta, and at the same time, he sends some of his party up north to investigate Mount Hood and Mount Rainier here. Arnold Haig went to Mount Hood, examined the Reed and Sandy glaciers, and Emmons went up to Mount Rainier. I don't know if he saw what later became the Emmons Glacier or not. He definitely saw Nisqually. And so this was he had conclusive evidence now that there were glaciers in the Western US. He's seen them on Shasta, Hood, and Rainier. If you look at the notes, Haig arrives in Hood about 2 to 3 weeks before King arrives on Mount Shasta. And Haig notes that there's glaciers on Hood. So one could argue that the quote unquote discovery of glaciers in the West was on Mount Hood. But hey, who got the money? Who's the director? He gets to write the paper and call it like he sees it. So he gets the claim of the discovery of glaciers in the West. So the first thing that King does is he sort of blankets the airwaves, so to speak, with this discovery. He publishes 2 articles here in the Atlantic Monthly. One is on the active glaciers within the United States, kind of a scientific article. There weren't very many outlets for scientific papers, so publishing in the Atlantic Monthly was one place that science papers did come out. He also published a travelogue here called Shasta, and this is about his adventure of climbing up the mountain and withstanding the cold, windy air temperatures. And then he also published a scientific paper for scientists now, obviously, in the American Journal of Science. And here it is, on the discovery of actual glaciers in the mountains of the Pacific slope. So, discovery of actual glaciers. This is key. So what happens is now throughout the United States, this news comes out. Here you have Salina, Kansas, Montpelier, Vermont. In the newspapers, they're talking about the discovery of glaciers in the Pacific coast. So this is big news. Apparently, people just didn't know that there were glaciers out here. You can see here Mount Shasta, Mount Rainier, Mount Hood have glaciers. So that kind of makes King's early fame. There were other things he did that made him equally, if not more, famous. But there's an issue here now. Edward Coleman in 1869 in Harper's Monthly publishes a travel log called Mountaineering on the Pacific. And here's a picture, or I should say a sketch, of Mount Baker as seen from Victoria, BC. And Coleman talks about his travels from Victoria up to the top of Mount Baker. Coleman was a member of the London Alpine Society. He knew what he was doing. And this is a lithograph of one of the sketches he made. And you know this is Northwest hiking. You'd see them on top of a log trying to get through the brush. So you know he's done this. So this travel log, he talks about going through the forest, up on the mountain, crossing some glaciers, getting to the peak, cutting ice steps, coming back down. So he talks about glaciers 2 years before King does. So maybe Coleman gets credit for this. So Coleman, years later, like what, 5 or 6 years later, kind of takes King to task about this. In the Alpine Journal, he questions King's claim of discovering glaciers. So here it is, the above mentioned statement as to the discovery of glaciers by Mr. Clarence King and his associates was an error. And the rest of the article goes through talking about, oh, this person saw glaciers, that person saw glaciers, they published it here, published it there. In fact, even down here in this kind of white area here, Thomas Dreyer, now Judge Dreyer, then editor of the Weekly Oregonian, made the first ascent of St. Helens and the first ascent of Mount Hood and published the accounts in the newspaper. And then he goes on and talks about other people. So there's this kind of, a bunch of other people have seen and published on glaciers prior to King. In fact, if you do more searching, here's the Royal Geographical Society, 1867. A minister from Portland climbs Mount Hood and talks about waters rushing from beneath the glaciers. The ascent of Mount Rainier, rocks each forming at the bed of a glacier. Agassiz, Louis Agassiz, the famous Swiss geologist who brought our understanding about the Ice Age, talks in one of his articles in the Atlantic Monthly. Little is known of the glaciers remaining in the high mountains of California. So he sensed that there were glaciers were out there. And then the boundary survey between Canada and the US, George Gibbs talks about seeing glaciers in 1869 up near the Canadian border, but on the American side. So there is this kind of knowledge out there that glaciers were present. So the story continues. John Muir had been hiking in Yosemite, and he's been talking about the formation of Yosemite Valley through the action of glaciers. And he actually discovers the glacier in the High Sierra. We now know it as Lyell Glacier. And he actually discovered it about a year before King discovered the glacier on Shasta. But his friends, that is Muir's friends, told him to hold off until he had better evidence. And what Muir did was, well, how do I know it's a glacier? Well, he looked for ice, and he saw ice in a crevasse. And then he measured the movement because he knew glaciers had to move. And that's kind of the modern definition of glaciers, perennial snow or ice that moves. So Muir actually cut some alder poles, put them in the glacier in a line across the glacier, and he came back 3 weeks later and saw that the poles in the middle of the glacier were downslope a few feet compared to the ones on the side. He said, aha, it's moving. So it's got ice, it's moving. This is a glacier. Okay, so now we get into science politics. Here's John Muir, only spent a year at the University of Wisconsin, didn't graduate, talking about glaciers and arguing about not only the formation of Yosemite Valley, but also the observation of glaciers. And on the other side of the debate is Josiah Whitney, head of the California Geological Survey, a Harvard man who just said there were no glaciers. And oh, by the way, Yosemite was formed by fault blocks, not by glaciers. And the other thing is, Muir found the glacier right in the area that King himself had done a lot of geological exploration for Whitney when he was volunteering for the California Geological Survey. King had tramped all over this place and never claimed to have seen a glacier in the Sierra. So King writes his book, the USGS report. It's actually the War Department before the USGS is formed, and it's the geological expedition of the 40th parallel. So King writes in, and you can read this today. He writes in this report, which is about the report is about 3.5 inches thick. It says, it is hoped that Mr. Muir's vagaries will not deceive geologists who are personally unacquainted with California, and that the ambitious amateur himself may divert his evident enthusiastic love of nature into a channel, if there is one, in which his attainments would save him from hopeless floundering. That's a slapdown. We can't write that kind of stuff anymore. So here it is. King Muir is who's already nationally recognized poet and writer and naturist, is having this academic argument with the elite of geological society, essentially. Here's the issue, and here's what everything's kind of revolving around. On this image of a glacier in the North Cascades, we'd all agree it's a glacier. Looks like a glacier, and that's kind of like what King did. You know, that's one of the ironies. King says, "Oh, I've seen glaciers. This is a glacier." Publishes the article. Muir actually does the science, and he gets lambasted for it. But proceeding on, here's a glacier or a bunch of glaciers in the North Cascades. We all know they're glaciers. You can see the crevasses. If you look carefully, you can see that it's ice down here, not snow. That's not the problem. This is the problem. Is this a glacier or is this a snowfield? Well, there's clearly snow patches around. This thing here that's of question. What is this guy here? This turns out to be the Schoolroom Glacier in Teton National Park. And if you look carefully, this here is a moraine, so you knew the glacier was large. Once here's a lake that has glacier flour in it. That's why it's that nice aquamarine color. That's from the grinding of rocks at the base of the glacier that forms the flour that goes into the lake. So you know it's moving. That's the only way you can grind the rocks. So this is a glacier. Here are the High Sierra. As a matter of fact, this large snow-covered area is the Lyell Glacier. But you look at this. This is G.K. Gilbert's photo in 1903. I would be hard-pressed for me to look at this to say if there's a glacier there or not. Certainly a lot of snow. So this was the argument that the professionals were using on Muir and others, that they're mistaking perennial snow for a glacier. And they were arguing that they couldn't tell the difference. Overlooking, in Muir's case at least, that he actually did the measurements and the observations. So after this, there was a number of quote unquote discoveries. Here you have Muir in the Sierra, Stone in Colorado, Ferdinand Hayden, one of the great geological surveys of the West, up in the Wind River Range, and Pumpelly and Orsdale up in Glacier National Park. So now begins kind of the flood of observations. Now that somebody's actually said that they're there, people are now discovering them more or less all over the place. So why doesn't these other people get the credit instead of King? Well, I think the answer to that is most people buried the headline. In all these other writings, it wasn't like, hey, we discovered glaciers. It was, hey, I took a trip up Mount Baker, and boy, it was really hard, but it was great, and we crossed these glaciers, and we went up top. So nobody focused a study on the fact that there were glaciers. It was always kind of a, oh, by the way, we saw one. And there was no particular description of the glaciers. So I think partly King came out to Shasta knowing that there were probably glaciers out there, that there wasn't any quote unquote scientific paper on them. So he could get out there and claim the right of scientific discovery. And that's why he kind of gets it, rather than somebody who just reports it in a newspaper as just some observation. So as late as 1885, they were still talking about what is a glacier. At the general meeting at the Philosophical Society of Washington, the symposium, probably an informal symposium on what is a glacier. And these various scientists, here's Emmons, for example, G.K. Gilbert, were talking about how do you define a glacier. And you know, it seems dopey now to us, but back at the time when you're trying to figure this stuff out, these were reasonable arguments. Like, for example, here's South Cascade Glacier down here, photographed. So this is the accumulation zone where you get more snow falling than melts off. Is that part of the glacier, or is that just a snow field? Is the glacier really down here where there's exposed ice? Or is this whole thing the glacier? That was kind of part of the debate on how do you define all this stuff. Okay, so I kept mentioning G.K. Gilbert, perhaps the preeminent American geomorphologist of his day, did a lot of work on the San Francisco earthquake, among other things. He starts looking at the changes of glaciers. So now we've kind of gone from the geography of glaciers, where are they? Now people are beginning to study their changes. And he says here that between 1903 and 1883, so about 20 years, the glaciers haven't changed size hardly at all. But they do soon after that. Harry Reid, professor at Johns Hopkins, eminent scientist, big into seismology, internationally known. He had kind of a soft spot for glaciers and did a number of studies out here on Adams and Hood, trying to set up actually a photo sites, observation sites for other people to come to track changes. So he kind of provides the baseline, hoping other people would come in with measuring instruments and photographs, cameras, to take photographs to depict how the glaciers are changing. One of the interesting things about Reid is that he was one of the founding members of the Mazamas, the Portland hiking club that still is in existence today. So he was on the ground floor of that organization, despite the fact that he lives in Baltimore, Maryland. So, the Mazamas was it still is a huge hiking club, but it was even bigger back then. This was kind of in the era of getting man back to nature, out of the dirty cities, and try to understand and become better acquainted with nature and become more healthy with the fresh air, and this is the idea of baseball and just being outside with athletic activities. This was all part of that. And this was in this era of the late 1800s. You have the Adirondack Mountain Club, the Sierra Club, and the Mazamas all forming in response to this interest. So the Mazamas are unique of all the hiking clubs because baked into their DNA is an interest in glaciers. And here in the Historian's Report of 1895, which is in Volume 1, Number 1 of the Mazama Bulletin, they talk about it should be the duty of this organization to measure and delimit glaciers on each peak we ascend, and to track how they might change in time. And according to the laws of the Mazamas, you have to climb a peak with a glacier on it in order to be a member. So they were very early in on this. And here's the table of contents for their first volume. And after they figure out the song of the Mazamas, and they figure out what the name means, and they figure out all the badge and colors, they get down to the science in the bottom. And here they're looking at the glaciers of Mount Adams, ice caves of Mount Adams. And the Mazamas, unlike a lot of hiking clubs, had a real research arm to it, and they still do. Here they have glacier observations. This is a map of an aerial survey on Jefferson and the southern volcanoes, looking at the
Yeah.
glaciers.
You like chestnut stuffing?
Mhm.
I found some chestnuts before it's too late.
Somebody has their microphone on.
Yeah, I found a bad one.
Thank you. And here's one of their aerial photographs. Here's 2 measurement points. So they're going to measure the changes here in the Elliott Glacier. Here's one of the members here with a dial, and he's wearing a tie, so he's serious about whatever this might be. So the Mazamas, unlike most other hiking clubs, had a serious research effort. The Sierra Club a little bit, the Mountaineers of Seattle a little bit, but it's the Mazamas that produced a lot of data. They worked with scientists, and they still do today, actually. Here's the Committee on Glaciers, the American Geophysical Union. The American Geophysical Union exists today. 20,000 scientists gather every year for their annual meeting. Here, Harry Fielding Reid is in it. Down here, here's Francois Matthews. He's the guy who coined the name Little Ice Age. This is an important committee. And here we have Oliver Caroline from the Sierra Club, Ken Phillips from the Mazamas. He was a hydrologist for the USGS, but he was with the Mazamas providing data to this National Committee on Glaciers. So these hiking clubs kind of filled in the science before the scientists, or before many scientists got out there. You had the early scientists that I talked about a little bit, but then it's these hiking clubs that make these observations on which we base some of our studies today about glacier change. And then since World War II, you had the rise of geophysics and the application of physics to glaciers, and how do they flow and how do they recede and things like that. And it was mostly actually initially Caltech with Bob Sharp, Barclay Kim, and Mark Meyer. And Mark Meyer eventually went to the USGS, and then Ed LaChapelle from the University of Washington. But this is the core group of glaciologists in the United States after World War II that really accelerated the program on understanding glaciers to international recognition. Okay, so why study glaciers? Well, glaciers melt and they supply water. This modeling graph down below illustrates it really nicely. This is water discharge on the left and time on the bottom there. And the rain and snow melt is in red. So basically rain and snow, it melt, it contributes to the stream flow. And then you have glacier melt. This is in black. So when it's cool and rainy, you get a lot more rain, a lot more snow melt, which contributes to the rivers, and not much glacier melt because it's cool and rainy. But if you have a hot, dry summer without much rain, that's when glaciers really melt the most. So the flow from watersheds that have some glaciers and some ice-free areas has a very stable flow on a seasonal basis because of the opposite effects of rain and glacier melt. This is also a model of what will probably happen in the Hood River Basin. This is Mount Hood. This is Hood River down here, and this is the Elliott branch of the river. And the expectation is that with the glaciers getting smaller and smaller and smaller, there'll be less and less melt contributing to the water flow, and the total discharge then will be reduced to only what's coming in from snow melt and rain. And this color coding is to show you what branches of the river are contributed from melting glaciers. This is particularly important actually in the Hood River Valley because you have a lot of pear and apple orchards. And if you lose half your water in August and September due to the loss of glaciers, that could affect your crops unless you water artificially. So there are some very immediate consequences of this. Of course, you all know about sea level rise, and here's an example from the IPCC report of 2019. You can see the sea level is rising. Here's 1900, and now it's rising really rapidly. And this is the family of expectations, the envelopes of expectations. And this includes modeling as well as observations. So at least over the historic period, we have really good modeling estimates of how much water should be going into the oceans and how that's raising sea level. And here's the projections based on those models, understanding something about the amount of CO2 in the air. So you can see this family of curves. And since I've been watching this over the years, it looks like it's high for 1 meter sea level rise. And I think that's going to be the normal. I think we're definitely going to get that. It's a question of, well, are we going to get much above that or not? But that, to me, at least, is the most likely scenario, unless we suddenly shut off our carbon dioxide input today. And even then, we're still going to be suffering some sea level rise. So on the right here, you can see this pie chart that half of the current rise is due to thermal expansion of the ocean waters. As the waters get warmer, they expand. Like you would have a pot of water on the stove, and if you fill it all the way up and then turn on the stove, it's going to overtop and spill out because the water is expanding long before it boils, and you'll have water all over your stove. same things happening in the ocean. So this dark blue are glaciers and ice caps. Like Iceland has ice caps. The Juneau ice field is an ice cap. Then you have alpine glaciers. Oh, excuse me. This is Greenland here, and this is Antarctica. So even though Antarctica is really big, like the diameter is roughly the width of the United States, it produces the least amount of water right now. Greenland, which is about the size of the 13 colonies, produces more water than Antarctica does. And then the little glaciers and ice caps together produce about as much water or a little more water than Greenland. Why is that? Even though they're very small and they won't contribute that much to sea level rise, they'll contribute some. It's because they're the ones melting like crazy right now and issuing water into the oceans. Greenland is coming online now and is beginning to melt more and more. So that's the second major contributor. And Antarctica is still slowly coming online. And even though it's huge, it's releasing less water than the other two, which is maybe opposite to what you might think. You know, in the news media, they're always kind of focused on Antarctica, focused on Greenland, but it's these other smaller glaciers, like from Southeast Alaska, that are just retreating like crazy and contributing tons of water to the oceans. And then hazards as well. We have debris flows. You can see here Elliott Glacier on the right-hand side. That's retreated back. You can see the moraines here on both sides. They're the little ice age moraines, you know, that were created at as late as the middle 1800s. They're oversteepened on the inside, and they're subject to failure. And this cut here is a failure of the moraine into the Elliott stream here that eventually bulked up, came down the side of the mountain. This is in 2006. Some of you might have remembered this. This is just before Thanksgiving. And here's this debris flow just north of Parkdale. And then coming out the White Glacier on the east side, here's Route 35 covered in boulders right at the White River Bridge. So these debris flows caused by oversteepened moraines that the ice from the glacier no longer buttress, fail and create debris flows that are important hazards. Okay, back to the bigger picture of what's happening in the Western US, not including Alaska. This is a map of where all the glaciers are. The bold here is the number of glaciers in the total area, and the smaller, lighter numbers are the number and area of perennial snowfields. We include snowfields because they're an important hydrologic factor. And then the color coding here, this is the US Forest Service, different regions. We're working for the Forest Service on this, so we color coded it according to their regions. So I won't go through all this, but just to let you know, there's about 1,300 glaciers that we're aware of in the Western US, and that's almost 370 square kilometers of ice cover. And then even though there's more snow, almost as many snowfields, because they're so small, they're only like a fraction of the glacier area. To put it in some context, if you've ever been to Austria, we have about as many glaciers in total glacier area as they do in Austria. And Austria is, I don't know, I think it's a little smaller than Montana. So this is what glacier change looks like. Numbers obviously on the left. To describe this for you here, so the lighter pastel-y colored circle, that's the number, and then the more vibrant color is the area. So let's look at this one up here in Washington and Oregon. If this was all blue, it would be no glaciers, no glacier area has been lost. But now it looks like a quarter of it, quarter of the pie has been taken out and turned red. So that's 25% of the glacier area in Oregon and Washington has been lost since the 1950s, about the 1950s. Here in Montana, it's almost half. Colorado and Wyoming, almost half. And then the numbers, um, you know, you just lost a few here in this area, but they're obviously the big ones because their total area loss is quite large. So, you know, you won't have time to absorb all this, but this is kind of the way we look at it for glacier change. One interesting thing here in this funny symbol here is that in Oregon and Washington, and this is mostly Washington, we have more glaciers than we started out with. The area has shrunk by a quarter, but we have more glaciers. And we puzzled about that for a while. How do you get more glaciers if glaciers are shrinking? Well, very simple. Here we have the main glacier coming down with tributaries. The main glacier retreats, and now we have all these tributaries. So we went from the way we do it, we counted one glacier here, we outline it and put it in our database, and then 50 years later, we go back and we outline it again, but now we have 5 glaciers. So the total area is smaller, although the number of glaciers have increased. So that's kind of one of the wacky things we did some head scratching about when we first encountered that. Focusing on Oregon here, and I'm beginning to wind up. Here were all the glaciers in Oregon. Probably most of you know all about this, about the volcanic peaks. The yellow here are the seasonal snow patches, the perennial snow patches. There used to be a glacier, a couple of glaciers in the Wallowas, but there aren't anymore, according to our updated survey. And here's Glacier Peak in the Wallowas. This is the Benson Glacier. You can see this is back in 1920, a very nice, sizable glacier. And if you know what you're looking at, this smoother bedrock here is where the glacier used to be, probably in the Little Ice Age, 50 years before this. So in 1996, you can see how it's really shrunk. This is a photo by Dave Jensen. Let me go back. There it was in 1920. Here it is in 1996. Just a small remnant up here. And then when I went up there in 2015, it's even smaller. I'll go back. So now it's actually, it's kind of partially shaded by this peak and probably get a lot of avalanches. So maybe it's a little less resistant to climate warming because its conditions have changed. It's shadowed. It still gets a lot of snow from avalanches, but the glacier area is smaller, so the snow covers it better, less exposed ice. So this might be what we would call it now a climate insensitive glacier, but this has gotten so small now that it no longer moves. And by definition, it's not a glacier. The ice patch is still there, but it doesn't move. So we consider that a perennial snowfield or ice patch, but no longer a glacier. One last glacier to look at, here's the Collier Glacier coming off North Sister. Here it is in 1910, filling the whole valley. I couldn't get the same perspective, but that glacier was all the way through here. Now by 1934, it's down in here. By 1973, it's retreated from here up to here. 2004 changed a little bit, and here it is today. And we hiked up there last summer. So you can see these glaciers, and this is what the fabulous contribution photography he makes. You can really see how the glaciers have changed. And from those photos, we can estimate glacier change before there were measurements of glaciers. And we've done that for Mount Hood and Three Sisters. This is glacier area here. And all these lines gray lines are individual glaciers. Here's Elliott Glacier up here. Total glacier area here on the right-hand side. So the total glacier area is this bold line. And the reason why it only has a few points compared to, say, Elliott Glacier is that these are the points where all the other glaciers have a measurement of area in that year. Whereas Elliott Glacier has a lot of measurements over time, but only all the other glaciers have a measurement at this year. All the other glaciers have a measurement on that year. So it kind of creates a slightly different and maybe a smoother graph. And here, Three Sisters, same thing. This shows here this little advance, and you can kind of see some of that here if you look carefully up at Hood. This is the mid-century cooling of the 50s and 60s, when glaciers, if they didn't reach equilibrium, they actually advanced a little bit. And that's a pretty well-known response. So if the Earth does get a little cooler, the glaciers will definitely advance. So here's the super depressing part. We did some modeling of glaciers in the Olympic Peninsula, because they're the low elevation ones. They're the first ones that would go. And under our climate projections for the next 100 years, you can see that the area of these glaciers just falls off the map. And by 2070, we just don't have any more glaciers there. And the volume itself does the same thing, except that it becomes vanishingly small by 2050. This is under business as usual. I'm not normally a pessimist, but I don't see us doing anything different than business as usual for the next, for the next 50 years. I hope I'm wrong. If we can reduce carbon dioxide and other greenhouse gases, we have a chance to save some of these glaciers, maybe not these glaciers. So what's happening here in the Olympic Peninsula is going to happen west-wide. It's just going to happen here kind of first, and the other glaciers, except on the highest peaks like Rainier and Baker, will follow. So talk to your senators and talk to your representatives. Okay, thank you very much. I'm done.
Thank you very much, Andrew. Now let's open it up for questions in the chat. I think there was at least one chat I saw.
That's right. There's one chat here. Andrew, are you suggesting there was no understanding of, experience with, or language regarding glaciers by indigenous peoples prior to the arrival of Whitney and his associates? That glaciers were only discovered after Whitney's arrival.
I assume that Native Americans knew all about glaciers. I just don't have any references or information to say, oh yeah, we saw this piece of ice on this mountain. I just have no information on that. But I assume they did. They've been all over the place and in the high country. So I assume that they knew about them. I just don't have any evidence of it.
It was kind of a scientific aspect is what you were presenting was the traditional science.
Yeah, that's right. When we say who discovered it, often people know about things like cave paintings. The local farmers knew about the cave paintings, but it's scientists who come and says, oh, this really is a cave painting, and I'm publishing it in a peer-reviewed journal. They're the ones who get credit for it. And hopefully they acknowledge the local farmers, but that's kind of the rules of the game.
Got a question for you. This is Charles. I've lost my video signal, so I can't see you, but I still have my audio. When did glaciers disappear from Yosemite Valley? And I know that what I hear here is that you have the coastal mountains versus the Sierras. Could you hear me?
Oh yeah, yeah. You were still moving. I just wasn't sure if you were going to say something else.
No, I'm done. I can't see myself, so I'm blind.
Okay. Yeah. It was the last ice age. Even the little ice age, the glaciers didn't get big enough to carve Yosemite Valley. So it was at least 100,000, no, yeah, about 100,000 years ago. Even though the end of the local ice age around Puget Sound might have been 15,000. California was a lot warmer, and you had to have really big glaciers down through there, so that had to be at least 100,000 years.
Wow, thank you. And also, I didn't hear you mention glaciers on the Olympic Peninsula. Now those are in the coastal range.
Yeah, no, that the last part of the talk about the prediction of glaciers in the future were all about those in the Olympics.
Got it. Okay, thanks a lot.
And the thing is, those guys are, because they get so much snow there, it's a temperate rainforest after all. They're really low elevation. So as climate warms, a lot of the snowfall is going to turn into rain instead. So the glaciers won't be as nourished. And at the same time in the summer, it's going to be warmer, and then they'll melt faster. So those two effects kind of feedback, and those will be the first glaciers that disappear.
I see. Are there any other questions? Go ahead.
Yeah, Andrew, do you have any idea of how the livelihood or life of the glaciers in the West compares to like Europe? Where
Yeah, everybody in the temperate regions are doing about the same thing. They're all receding. I just received a report that is a bound volume in the mail about a month ago from Norway, and they're tracking all their glaciers and they have photographs of their glaciers. And I looked at those photos, and I realized all those glaciers were also retreating. I mean, I knew they were, but you could just tell by looking at the glaciers how thin they are. They're obviously not advancing, they're thinning and retreating. And I was really kind of struck by that you can look at the data, but when you see those photos, it's like, wow, yeah, this is definitely happening over there as well. In Switzerland, they're losing their glaciers. Yeah. Yeah. Everybody's losing them.
Yeah.
if anybody has any questions, please unmute and possibly turn on your video so we can see who's asking questions.
Well, I've completely lost my video, so I'm hanging on with the audio. So you can see me, but I can't see you.
Yeah.
I would like to make one comment. In the news media, you hear about the Doomsday Glacier.
Yes.
Carolyn, good for you.
Hi.
Hi. Yeah. So the Doomsday Glacier, so to speak, is in Antarctica. And yeah, the glacier's receding. It should start receding more quickly. And Doomsday, unfortunately, is a bad term. It probably will in the next 10 years. It'll start retreating without pause. It'll just continue to go because of a certain instability. But the thing is, it's not like the reporter talked about it as a house. And if you slowly pull out the bricks of the foundation, as climate warming is affecting this glacier, the house collapses. And therefore that's his sense of the Doomsday Glacier. It's more like pulling the chunks out of the tires of a car, that once those are gone, the car begins to roll downhill. And that's the thing with that glacier, the Thwaites Glacier in Antarctica. That will continue to accelerate its retreat over a period of time, and that period of time is over the next 100 years. So it's not like it's going to catastrophically raise sea levels by a meter, in a decade. That's going to take a long time for it to do its thing. That's the only thing I want to say.
Got it. Anyone else?
Andrew, do you want to say anything about the change of the geomorphology in the valleys, the river valleys, and potential for hazards, with increased hazards from landslides and such?
Yeah, that's a good point. Yeah, and that, I mentioned the debris flow hazards from these glaciers, particularly the ones on the volcanoes, because they have these huge unstable moraines more than other places. And that's going to be a persistent hazard in the future as these glaciers have receded and they no longer buttress the moraine sides. The ice is now gone, the moraines are very steep, and they'll continue to fail. So this kind of hazard and subsequent debris flows we're going to see for a long time, the next century or more, that will episodically get one of these things. When we have kind of an atmospheric river raining down on these volcanoes, we're going to continue to see that. And I think you probably know better than I do, Carolyn, but then you have these responses to the streams with all this debris flow, and the streams begin to change course and do unpredictable things. And if you have any access highways in that area, you're going to be facing a lot of maintenance costs. Did you want to add anything to that, Carolyn?
No, except pretty much what you just said. I'll just say that the nature of the stream flow will change as well. It'll be much more flashy, so we can expect more floods. I guess you touched on that in some ways as well already. But kind of the nature of things will change, and I think the nature of the valleys will change. It seems likely that with streams moving across valley floors with more water coming out in a shorter amount of time, that we may have less vegetation growing, less not so healthy riparian zones, maybe a different environment for fish, and maybe more flooding. So yeah, just with that flashiness from that increased water coming, the amount of water coming down in a shorter period of time, I think it's going to be really noticeable by a lot of people.
Yeah, that's a good point. Yeah, so we're going to be seeing these changes for the foreseeable future.
Yeah.
I have one question with regard to atmospheric rivers. Andrew, have they always been there, or are they just becoming more intense?
I thought about that question myself not long ago, and I talked to a friend of mine, and I said, well, have atmospheric rivers always been there, or is it just a new name that we've put on them? And he said, yeah, it's just a new name. There's been lots of documented atmospheric rivers in the past that people didn't name as such. Having satellite imagery kind of helps you see these things. And talk about Native American records. There are written down accounts of what we now recognize as atmospheric rivers reported by Native Americans a long time ago. So this is something very common. Are they more frequent than past? No, I don't think so, but that could change.
So when we had our atmospheric river last week, I took this picture from my dark sky, and it looks like a serpent, but that was the atmospheric river that was traveling, and that hit Portland so hard in the last 10 days.
Well, that's scary.
It is scary, and it goes all the way to Indonesia. But using dark sky, I can twist the world any way I want it, and I can actually see these things occurring, but they're primarily in the Pacific.
Yeah. Yeah, there's other atmospheric rivers elsewhere in the world, but we don't care about those, right? We're only worried about the ones that hit us.
Sorry, if that was not the atmospheric river, that was me. I'm sorry about that.
Well, that's why I said it was scary.
Yeah, pretty scary, all right. Okay. I couldn't see it from the back. Okay.
Andrew, what's the name of that book you mentioned early on? The fellow who was the geologist as well as the road.
Yeah, that's Clarence King, and here I can show it to you. This is the one I like. I like here. It's King of the 40th Parallel, first director of the USGS, Carolyn.
I see.
Who's it by? James Moore.
Jim
Thank
Moore.
you.
Oh, okay.
And then you have this other one called The Explorer King. And that's by Robert Wilson.
And
I tell you, it's a fascinating guy. It's worth your time.
and
Well,
there's another one of my shots of the atmospheric river at 3 o'clock in the morning last week.
Wow.
And there seem to be two of them, one going up into Siberia and the other one going across the Pacific over towards Portland on the West Coast.
Yeah, yeah.
Boy, wow.
Yeah, thanks.
Oh, you're welcome. Thank you very much. Sorry, it changed to me. I couldn't see that, but yeah, that's okay. Are there any other questions? Well,
Yeah,
if,
I have a quick question on Antarctica. A lot of the big calvings have been floating glaciers. What percentage of floating glaciers are in Antarctica? And they don't affect climate, river, ocean rise.
Yeah. Okay. I'm going to give you the full story, Larry. The Greenland melts from basically you're getting all the melt from the ice sheet itself. It runs off the ice sheet into the ocean, generally speaking. In Antarctica, there's almost no surface melt. It's all melting caused by warm ocean currents underneath the ice shelves. Where the glacier flows out into the ocean, and Larry, I know you know this, flows out in the ocean, part of it begins, the seaward extension floats out like a shelf. When it's floating, it doesn't make any mass contribution to the ocean. So when that breaks off and it floats away, sea level doesn't change. Same thing when you have a glass full of ice and water, you let the ice melt and the water level doesn't change because the ice has to be floating, but it's because the mass is all the same. The thing is with Antarctica, it melts underneath the ice shelf, the landward side, which reduces the area of contact between the glacier and the subsurface, and that allows the glacier to flow faster. So it's pushing more ice out into the ocean. That's what's concerning everybody.
Okay. Well, we really thank you for a phenomenal presentation, Andrew. Thank you so much. I've learned so much tonight.
Sorry for going on a little bit long, but you know, when you get an interesting subject, you just can't stop yourself.
I know.
Great
And I
job.
remember how my grandparents used to talk about the Mendenhall Glacier when they traveled to Alaska in the 1930s. And I went up there and I could hardly find it in the 1970s and 60s.
Yeah.
But anyhow, I have thank you very, very much for this
Sure,
wonderful
thank you.
presentation. It was just fantastic. And this is one of the beauties of what we do here. And I'd like to suggest with Christmas coming and that anybody would want to give a membership in the Columbia chapter. Pardon me, Lower Columbia chapter. You can do that just simply by going to our website, iafi.org, and there's a form there you can fill out for the person that you'd like to give it to. It's just fascinating what we've learned over the years. It's just incredible. I want to let you know that this is our last meeting in 2022. We never meet in December because our meeting is so close to Christmas. And then to top off the new year, we're going to work on this chapter because we've had a change in our board. We have work to do, And so we're not going to meet in January, but we are going to meet in February, and it's going to be a great meeting. We're working on that now to get our speaker and so forth. And so we'll be starting off the new year on February the 16th, 2023. And so with that, I want to thank you very, very much. And I wish you all a wonderful evening. And we also wish you a wonderful holiday season. A happy Thanksgiving, and Merry Christmas, and a Happy New Year. And we'll see you next year on February the 16th, 2023. I guarantee you it's going to be a great meeting. Thank you so much. Good night.
Thank you, Lloyd, for doing behind the scenes work tonight.
Yes, absolutely.
It was
It will
easy.
be posted. It will be recorded and posted to both websites.
Yeah.